Okay, so we're going to go ahead and start talking about our quadrilaterals. This flow chart that you see, we are going to be bringing back every day and filling in more and more until it's completed and we're done with the notes for the unit. So we're going to start off today with quadrilaterals and parallelograms. That's going to be the notes for January 6th. So to go ahead and fill in talk about quadrilaterals first. A quadrilateral is simply a four-sided polygon. And we learned with the sum of interior angles, a quadrilateral, the sum of the interior angles is 360 degrees. So these are your biggest characteristics about quadrilaterals. How this flow chart is going to work is everything underneath, all these other shapes are all quadrilaterals, and they will have these exact same properties as well. And then we'll just add more properties to them as we go. So let's take a look at the quadrilateral part of the notes before we move on and fill in the flow chart for parallelograms. For your quadrilaterals, as we already saw on the last page, we have polygon with four sides. The sum of the interior angles is 360 degrees. When you name quadrilaterals, you have to use all four of the letters that are at the vertices. You do not get to pick and choose what order to go in. There are certain orders you have to go in. The big thing is that you have whatever letter you start with, you have to go around clockwise or counterclockwise in consecutive order. So here, how we can name this, we're going to draw a little tiny parallelogram, meaning parallelogram. We can just start off easy. Parallelogram A, B, D, C. And notice how I didn't say A, B, C, D. We cannot do that. Okay, we have to go A, B, D, C. You cannot cut through. You have to go all the way around one way or another. If we wanted to start off with, let's say, B, we could call it parallelogram B, D, C, A. You can also go the other direction, B, A, C, D. But you have to go around. You cannot cut through. Another name, we want to call this, let's start with C. We can go, let's go the other direction this time. C, D, B, A. I'm not going to write all of them because there are a lot. We'll draw one more starting with the letter D. We can go D, B, A, C, or the other way around, D, C, A, B. We'll go ahead and stick with the D, B, A, C on this one. All right. So there's your naming. All right. The big thing that we have to remember is that the letters must go in consecutive order. So we'll write that here. Letters must go in consecutive, and we'll define that here in a minute. Spelling it wrong. I'm a math teacher. Consecutive order. And what that means is one after another. Consecutive just means one after another. You cannot cut through that parallelogram. All right. So with these two characteristics, these two properties, four sides, all the angles add up to 360 degrees, we can take a look at these six figures down here and determine, do they have these properties? They have to have both. Okay? Have to have both. We're going to circle each one that has each one that's a quadrilateral. So the first thing we need to do is on A, I see some angle measurements. Number one, I see four sides. Check on the first property. We have to make sure that all four of these add up to 360 degrees though. So in this one, what I'm going to do is I'm going to go ahead and I'm going to add these two. We're going to get 180. If I add these two together, I'm going to get 140. Now I'm going to add those, 180 plus 140, and I'm going to find out that I have 320 degrees. So we do not have enough degree measurements. So we're going to say this is not, because it's not 360 degrees. The next one, B, I see here that I've got four sides, so check. Okay. If we go ahead and do the same thing and add our angles together, okay, I'm going to add the two that are alike here. The 60 plus the 60 is going to give me 120 degrees. I'm going to take that 120 plus the 120. It's going to give me 240. Now, when I take that 120 and I add it to 240, I'm going to find out I come out to 360 degrees. So we're going to circle this one. This has 4 sides, and its sum of its angles comes out to 360 degrees. C's pretty easy. We can cross off the very first property of 4 sides. We have 5 sides here, so this is not going to be a quadrilateral because it has 5 sides. So D, again, kind of easy to see here. How many sides do we have? We have 3 sides, so this is not a quadrilateral. Quad meaning 4. So this is not it because we have 3 sides. Letter E, let's take a look here. Okay, I see 4 sides, so check on the first property. Let's look at this. 110 plus 110 will give me 220 degrees. And then when I take that 70 plus 70, this is going to equal 140 degrees. Now we're going to take those two and add those together. 220 plus 140. Look at that. We've got 360 degrees. So here we have 4 sides, and all 4 angles add to 360. We do have a quadrilateral. The last one, F. See here that I have 4 sides, so good so far. Okay, let's add up our angles, make sure we have that second property. 95 plus 95 is going to give you 190 degrees. And if we add that 85 plus 85, this is going to equal 170 degrees. We go to the side, we add 190 plus 170. We're going to get a nice 360 degrees. So we have 4 sides, and the sum of the interior angles is 360. Affirmative. We have another quadrilateral. So these are the only 2 properties of your quadrilateral. Okay? Now we're going to talk about the parallelograms. Parallelograms, we are going to take on our flow chart, and we're going to go straight down. Your parallelogram is a quadrilateral, okay, because it has these properties. A quadrilateral is not a parallelogram. It's not how this flow chart works. Everything that those arrows are going to has the properties of before, and we'll talk about that. So we're going to move down to a parallelogram, which is a kind of quadrilateral. So it's going to have the properties of your quadrilateral. It's going to have 4 sides, and we got a picture of one right here, and all 4 angles are going to add to 360 degrees. In addition to these, we have 4 more characteristics of parallelograms that we need to know. 4 different properties. What you're going to notice is your opposite sides are parallel, hence why it's called a parallelogram. They're not only parallel, but they are congruent. So opposite sides, so the top and the bottom here will be parallel, and they'll also be congruent. Same thing with the left and the right. Your opposite angles will also be congruent. So you go across the parallelogram from one angle, they're going to be the exact same measurement. Your diagonals, so if you draw a diagonal through these, okay, and we'll see this later, they are going to bisect each other. Each diagonal will be cut in half. And the last one here, consecutive, there's that word consecutive again, one after another. So if I take this bottom left angle and I go to the bottom right, that is one after another, consecutive angles. These are not going to be congruent, but they will be supplementary. We need to remember that is your add up to 180 degrees. So let's take a look at the notes here. Again, we're looking at these properties. All right. We have opposite angles are congruent, which is spelled incorrectly. Whoops-a-daisy. Oh, well. We have opposite sides are congruent. We have opposite sides are parallel. Consecutive angles, one after another, are supplementary, and your diagonals will bisect each other. It's exactly what we just filled out on that flow chart. All right. It is also going to have all the properties of your quadrilateral. 4 sides, and your angles add to 360. So with these pictures over here, what we're going to do is we're going to take each one of these and we're going to represent it, what it can look like if I give you a picture. Number 1, opposite angles are congruent. So here I'm going to draw 1, so I know this goes with number 1. So your opposite angles, so if I say, okay, this little angle right here is going to be congruent, I need to go to the opposite side of the parallelogram, and it will be congruent to this angle. Same thing with the other pairs. They will be congruent to each other. Notice that second arc I'm putting there, okay, because they're not all four congruent. Number 2, we'll label this guy number 2. We have opposite sides are congruent. So that means the left and right side here are going to be congruent. We'll put a tick mark. And the top and bottom will put 2 tick marks because they're second pair of congruent sides. Over here, number 3, we have opposite sides are parallel. So the left and right will draw a little arrow saying these are parallel. And then the top and bottom will put 2 of those little arrows, showing that those 2 are parallel to each other, the second pair of parallels. Number 4, we have consecutive angles are supplementary. So how we can represent this is putting some numbers in. Let's say this top left is 110 degrees. In order for the consecutive to be supplementary, we have to add to 180. So to get to 180 from 110, we need to add 70. So that means the next consecutive angle would have to be 70 degrees. So even if you look at it this way, the top right and the bottom right, if the top right is 70, to get to 180, that bottom right has to be, 110 degrees. And again, looking at the bottom here, if we have 110 on this bottom right, the consecutive next angle in line has to be 70 degrees. And then you'll also notice here with this that we're seeing number 1, opposite angles being congruent. Okay? Lastly, 5. The diagonals will bisect each other. So what we're going to do is we're going to draw on diagonals. The diagonals are going to cut across to the opposite angles. And what this is going to look like is, if we take a look, let me actually, if you've already drawn it, that's fine. Just pay attention to what I'm about to do. Here's my first diagonal. When I get that other diagonal that cuts through, it's going to bisect this diagonal into 2 congruent segments. So when this guy goes through, he's cutting the first one in half. But the first one is also going to cut the second one in half. You'll have a longer and a shorter one. They are both cut in half, and we'll do practice problems with this. Next, let's try it. Let's go ahead and look at this. All right, so number 1, I'm seeing opposite sides right here are congruent, and these opposite sides are parallel. When you have that, when you have one pair of opposite sides are congruent and the other are parallel, it does automatically make it a parallelogram. So here, these sides will be congruent as well. So x is going to be simply 12, right? So we got 12. And we're seeing here that AD, okay, is going to be equal to CB. So we're not putting congruent because I don't have the segment bars. We're talking about measurements when we don't have those segment bars. Okay? So here we're going to write in the property that we're using too. I'm going to shorten it. Opposite sides are congruent. All right, pause and get that down and move on. Next, we see here that we have, we're seeing a couple things, all right? I'm seeing that opposite sides are congruent, or sorry, opposite angles. So all of these are going to be parallelograms, all right? So here, when we have 70 for angle D, I want to find over here angle B, which is X. Well, the opposite sides are congruent, so that means X is also going to be 70 degrees. And then here, we're seeing that angle DAB, so angle D to A to B, is congruent to angle, well, DAB, A is that vertex, so here we're going to use C as the vertex, BCD. And the property that we used here was opposite angles are congruent. On number 3, we have this parallelogram, so we know it's a parallelogram, so we're going to have to automatically know here that not only are the left and right congruent to each other, but the top and the bottom will be congruent to each other. So if we want to solve for x, we're going to set these equal to each other. Okay, 2x plus 8 and is equal to 12, because two things are congruent, their measurements are equal. So here we go. I'm going to go quick. I highly suggest that you pause it and work through it. 2x plus 8 is equal to 12. Please pause, work it out. I am going to pause mine, solve it, and resume, so you're going to see the And solving, this is what we should have gotten. Okay, set it equal, subtract the 8, then divide by 2. X is equal to 2. Now we're going to take a look at finding y. So we see here that segment AD and segment BC are congruent. So again, we're just going to set these equal to each other. So we would have the y plus 3 is equal to the 15. Again, I'm telling you right now, pause the video. I am going to pause it, and then all of a sudden on your side, you're just going to see the answer pop up. Pause. Now, the problem, all we had to do was subtract the 3, and we got 12. All right? Try to make these videos as short as possible. On number 4, all right, we need to find x and we need to find y. Actually, go back to number 3. We did forget to put in here opposite sides. The property opposite sides are congruent. Number 4, we're seeing these angles, and we know here that we're going to have opposite angles are congruent. So here we have opposite angles are congruent. So to solve for x, we know that angle D and angle B are going to be congruent, so we set them equal to each other. 2x equals 50. And I'm not going to worry about pausing because this is a very, very quick solve. When we divide by that 2, we find out that x is going to be 25. Now, to find y, we need to remember that the property consecutive angles are supplementary. So here we have consecutive, that's how I'm going to abbreviate, one after another, angles are supplementary. So what that means is, whether you want to do angle D or angle B, they're both 50. If we look at angle D and angle C, they're consecutive one after another, they have to add up to 180 degrees. So all we need to do is take that 180, subtract that 50 degrees that angle D is, so we can see what's left over for y, and we're going to have 130. So y is 130. Next, we have a lot to solve for, so let's start taking a look here. We're going to solve for v, x, y, and z. So we can take a look. There's a lot going on here. What I want you guys to see is we're dealing all with angles here. All right. Another thing that we're gonna have to kind of see something here in a little bit. I'm going to start with x. Okay. I'm going to find x first. What I'm seeing here is a straight line, and I've told my students things we talked about last semester are not changing. Right here, I have a linear pair that are going to add to 180 degrees. So to solve for x, we have a linear pair. So all we're going to do is that 180, that's the whole line. We're going to subtract the 71 so we can figure out what's left over for x, and it will be 109. So x is going to be 109. We are going to now go find z. Let's pay attention to what's going on here. With z over here, we know that these angles right here are vertical angles, x and this angle over here. So if x came out to 109, that means its vertical angle over here is also 109. And then what we should see here is we have a triangle. And so what we're going to do with this is the Triangle Sum Theorem. All three angles add up to 180 degrees. So here we have triangle sum. So I'm going to add the 109 plus the 42. This will give me 151, hopefully. Subtract that from 180 so we can figure out what's left over. Z is going to be 29. Now, something weird's going to happen here that we need to bring back up that we talked about last semester. Again, things are not going away. We need to remember that our opposite sides are parallel. So we're going to put down here, opposite sides are parallel. Sorry, yep, that's not what I'm looking for. I was about to do congruent. Opposite sides are parallel. So what's going to end up happening here? Let's say if I want to find, I'm going to find v first. Okay, so v is over here. So we want to find V. V is only this section right here. It's not the whole angle. What we're going to need to see here is going back to our parallel lines and transversals. Okay? If our opposite sides are parallel, we could take a look at this and we can see we've got a transversal if we extend. If we extend this side right here and we extend this side right here, we're going to see this transversal. And we are going to have, I'm going to put a couple little arcs in there, alternate interior angles. It's a difficult one to see, but we extend those lines and we ignore everything else. It's just kind of hard to do. Okay? And alternate interior angles are congruent. That's what we learned. So to find V, we're going to set that 2V plus 3 equal to 42. So 2V plus 3 equals 42 because they are congruent. Again, I am going to pause. You pause. The answer is about to pause. All right, here's the work down here. We did come out with a decimal, and I went ahead and placed it on the line. Now we are going to go find Y. Last one. Y over here is just this guy right here. And we've got, again, parallel lines going this way also. So now we have another transversal. This is looking really messy. So again, we have a set of alternate interior angles. So we're going to set that Y is going to be congruent to that 38, meaning Y, we have alternate interior angles. So we don't even have to solve. It's just going to be 38. If you had to watch the video, please make sure that you ask your teacher questions. Because I can understand how it could be a little confusing, especially this very, very last one. Please make sure you ask questions about that when you get the chance to.